So yes, as you mentioned, it's a UKPN-led project where we've been looking at resilient communication networks. Click, please. So we've been hearing an awful lot about storms today, where you've got falling trees, severe weather, and flooding. Click, please. And what happens in all of those situations, we reach for our phones and that connectivity. And that's no different than restoration engineers, where they're trying to coordinate both with each other and central control centers to sort of coordinate that response. And that was actually discovered in Storm Irwin, where although DNOs do have their own independent methods of communication, very often restoration engineers first of all reach for their phones because it's what they were used to, it's what they're familiar with, and it has increased tools such as picture messaging, which can help alleviate the problem and increase that coordination, sending new configuration files over a data connection. Next slide, please. Another example of where this communication is required is here, where we've got a small town here, detailed in the top left picture, where a tree has fallen on the line between points 4 and 3. And this causes an electrical fault, which then causes the power to the entire town to go out. But then in the third picture, we can see that the power is being able to be restored from the bottom left-hand side through points 1, 2, and 3. And in the fourth picture on the other side, through substation B, through points 5, 6, and 4. And the other thing which is required to achieve this is communication. And so a signal will go out to each of those points, say, are you still operational? Yes, I am. Sent back to the control center, which is able to enable things like automatic power restoration and reduce the number of customer minutes lost by reducing the number of people affected. Next slide, please. So if we look towards future applications, we've got things like wind farms, solar, and EV chargers, or sort of DER devices, battery storage. Click, please. And you guessed it, that all requires connectivity as well. And that's much more of that sort of smart grid that we've all been talking about, that interconnectivity in order to balance that demand and supply. Next slide, please. So how is all this communication achieved? Throughout various different DNOs and network operators, there are different methods. So we've got satellite, which is generally quite high cost, low bandwidth, and we've got wireless mobile. So that could be private wireless mobile or public wireless mobile, which is generally one set of infrastructure spread over a wide geographical area to provide connectivity to lots of different assets. On the public side of things, that can be very low cost since it's already using existing infrastructure. On the private side, it can be higher cost, but still lower cost in providing a dedicated satellite link to each site. You've also got technologies such as microwave, which can provide point-to-point or point-to-multipoint. That has the advantages of being wireless and relatively low cost to install, but does still require that dedicated infrastructure. You've got ADSL, which is really great from a resilience perspective because there is built power resilience into the network. So there was power autonomy if the power went out, that communications network was still available. Unfortunately, it's been switched off in 2025, so we can't rely on that one much longer. And finally, we've got fiber optic, which is the way the technology is going. So this provides a massive amount of capacity, but it's also relatively expensive to install. And there's an ongoing debate about the power autonomy that's going to be put into that network, whether it will match the ADSL network and how far it will penetrate into it. Will it only go to the street cabinet, or will it actually go to the premise at the end? Because in order for fiber optics to work, unlike ADSL, it requires powered infrastructure, which would require backup. For resilience, we would ideally want two of these different technologies to provide independent communication links. But of course, we want to do this in the most cost-effective manner as possible. Next slide, please. So looking at some cost and compensation, during Storm Irwin, £46 million was paid out in compensation. Or part of that could have been reduced by a faster restoration, which could have been assisted by the control engineers being able to use their mobile phones, because what was discovered by two DNOs, engineers reached for the phones, but because the power to the mobile infrastructure had went down, the mobile infrastructure didn't work, and therefore they couldn't effectively coordinate, slowing down the response. Without communications, it's also harder to do automatic power restoration, and so some of that compensation could have been reduced through increased connectivity. One organization, looking more on the cost side of things, one organization has proposed in their RIIO2 ED2 proposal, £5.5 million in looking at private mobile radio communications. And this is sort of still analog technology, so you wouldn't get any of the benefits of picture messaging or sending data configurations over that. Second organisation has proposed £1.5 million to provide IP communications to 500 primary substations. Third organisation has seen costs of up to 100,000 providing IP connectivity to certain substations. And a fourth organisation has estimated about £10,000 for an installation plus £120 monthly ongoing cost for providing that resilient IP connectivity to DNO assets. So once you start adding those costs up to the 6,400 primary substations and a subset of the roughly 400,000 secondary and some subset of the DER sites, that goes into the hundreds of millions of pounds to providing connectivity to each of these sites and enabling that sort of smart infrastructure. Next slide, please. So how can we reduce the costs? One of the ways of reducing the cost is by using public infrastructure, and that's been demonstrated by some DNOs who are using existing public infrastructure. The costs are substantially less using public 4G than using ADSL or satellite. But the challenge that multiple DNOs find is there's a lack of oversight and visibility of those public networks. They don't know what exactly is going on in them. They don't know how much resilient they are. They don't know when the connectivity will go down. So kind of compromise between these two things happen. So one example of that is with FirstNet, which is a network deployed by AT&T in the United States of America, which was a network built for emergency responders, where they have priority communications. So there's dedicated infrastructure just for them to provide resilience, but they also use a lot of public infrastructure, and that reduces the cost quite significantly to order of magnitude same price as what a regular consumer would pay, sort of $30, $40 per month per site. ESN, Emergency Services Network, is equivalent in the UK, where we're replacing Airwave and deploying a 4G network for the blue light services to utilize, and that is using existing infrastructure rather than replacing with a new system similar to Airwave, and that is predicted to save £200 million per year. So how can we bring together those two issues, the low cost of using public infrastructure, but the lack of visibility, and other issues such as industry consolidation? So although there's 4 mobile network operators or NMOs in the UK, and that's actually broken down into 2 main groups, Vodafone and O2, which form Cornerstone, and 3 and EE, which form CTEL. So in these agreements, they will share infrastructure, which then reduces the overall resilience. So even if you think you have the availability of 4 networks, you actually might only have the availability of 2 or 1 network. And additionally on that, there's talk of a merger between Vodafone and 3. So if that merger goes through, then that would only become 3 or potentially 1.5 networks. Looking forward in time, also looking at new data consumption profiles, where as time goes on, utilities may use more data consumption and therefore require more resources, and that might require rescoping of the communication requirements. And finally, looking at the potential coverage issues. So for an urban DNO, where there's already demand for the mobile network operators to provide connectivity for the primary customers, i.e. consumers, users like you and me, they will have that mass infrastructure, but up in rural areas, they might not have that mass infrastructure because there's no commercial incentive for them to provide it. and therefore it's difficult for a DNO to provide one solution for the entire network area if they don't have that required coverage. Next slide, please. So one of the areas which we've been looking into is, can we reduce that dependence on public infrastructure or lack of visibility on public infrastructure, and increase the information exchange between network DNOs and mobile network operators? And there's actually a lot of supporting work in this area. So as Guido mentioned, the readiness stormed ahead by the Joint Committee on National Security Strategy highlighted this interdependence between electricity networks and communication infrastructure, and suggested it's an area that should be investigated. The Electronic Communications Resilience and Response Group, which has members such as CPNI, the Home Office, the Cabinet Office, and DCMS, also published a report after Storm Irwin, which one of the main findings was the critical interdependency between communications and power infrastructure. So how can we solve that interdependency? It's through allowing greater information exchange, giving the DNOs more oversight over what the MNOs networks are capable of, and giving the MNOs more insight about what the DNOs can provide. So there is a technical standard provided by the 3GPP, which is the Mobile Networks Standards Organization, which is looking at providing exactly that, providing additional information for DNOs from mobile network operators, such as if this mast site goes out, then these are all the assets which will lose communications, or if the power goes out, this mast site will have 15 minutes of battery backup, or 1 hour of battery backup, or 4 hours battery backup, therefore enabling the DNO to prioritize restoration to certain areas which might lose communications faster than others, in order for them to effectively respond to the disaster. Similarly, there's a lot of work going on in the EU at the moment, where some new regulation is coming out looking exactly at reducing interdependency between communications and utility infrastructure. And based on that, there's a lot of interest from both the DNOs, such as EDF, and the MNOs, such as Vodafone and Deutsche Telekom, in order to enable this reducing interdependency and collaboration. Next slide, please. So specifically for our alpha objectives, we want to integrate the DNO and MNO, so mobile network operators systems, in a proof of concept demonstrator. Just sort of as I outlined before, we're detailing to an a DNO, what assets will lose connectivity if that MNO asset goes out, and therefore providing more information to the DNO and for allowing them to make informed decisions. Click, please. There's another aspect of tackling a similar problem is using the facility at PNDC, where we have two 5G networks, a private network and a public network, and we have DNO infrastructure such as PowerOn, where we can create a system where alerts from the mobile network operator, for example, loss of mains, is fed out of that system and into PowerOn to allow control and restoration engineers to have a fuller picture of what's going on. We would develop a testbed to show that, explore the challenges about the integration with the various different partners in the ecosystem. So that's things like Nokia and Ericsson on the mobile telecoms side of things, or PowerOn on the DNO side of things. And since this is an open facility, which was partly funded by our member organizations, DNOs would be able to come and visit the site and see how exactly their system could be integrated to make it work best for them. Click, please. As an additional way of tackling this problem, where we wanted to de-risk the approach as much as possible, would be creating a small monitoring device which could be deployed in substations to monitor the surrounding networks. And if a network was to go down, that can be sent back to a centralized database and then compared against historical power outages or power outages at the time to sort of reverse engineer a resilience map of the surrounding base stations. For example, in the diagram, there are two street level masts at the lower end of the picture, which might provide 1 hour of battery backup, and therefore the power can go out and communications will maintain for 1 hour. However, the mast mounted at the top of the building, at the top of the diagram, because of space, cost, and weight limitations, might not have any battery backup, and therefore any devices connected to that mast would lose communication instantly, where devices connected to the other mast would be able to keep communicating. And by developing a device like this, we would be able to understand independently what the resilience of the communication network is in different areas of the network, and therefore decide intelligently where more resilience is required. For example, if there are 4 masts, each with a sufficient battery backup in that area, it may not require any additional resilient infrastructure, where if there's only 1 mast with no battery backup infrastructure, it may be worth putting resilient communications or backup communications in the form of a satellite. Next slide, and then I think we're on to questions and answers.
Thanks a lot, Ross. We haven't had any questions come in yet, but I've got one quick one. I know in other sectors like rail and road transportation, they proactively engaged in the development of 5G.
Yes.
Is there a history of the energy sector actually trying to influence the development of future communication systems to meet the needs of the sector?
Historically, it's not been very successful. It is an area that both the JRC and the UK is interested in pursuing. It's one of the strategic objectives in order to get more influence over those standards. So it's really good that this one area has actually made it to the start of that standardization process, because that's how you get things into the ecosystem, where first of all needs to go into standards through the standardization process, and then taken up by vendors such as Nokia and Ericsson, and then once it's implemented by them, then actually deployed by the mobile network operators.
And another question I had was around communications from DERs. Have you considered the sort of consumer consenting requirements that might be around that, or any user acceptance testing to know if people are actually going to be willing to have their devices communicating with an energy network or other organization?
I think that depends on the level of DNR device that you're going to, where if you've got a relatively large wind farm, that would be a sort of a business agreement. But if you're thinking DER down to the fridge or the EV charger in a consumer's house, then that is sort of different approaches. Using the public infrastructure for the latter, so a device in a consumer's house would be possible, but I would imagine that would be implemented through some sort of flexibility services where there's an incentive for them to be connected to the grid. So in high periods of electricity, they might shut off, and in low periods they would get a lower price.
So you'd be looking at bigger assets or the aggregation of smaller assets via an aggregator or other intermediary anyway?
We're predominantly looking at the most cost-effective way of providing communications to any asset which would be useful for a DNO or DER provider. But generally, yes, larger assets is what we had in scope, and because the smaller assets, if they were to lose power, it wouldn't cause such effect on the grid stability, where if a large wind farm went out, it would.
Great. We've just got one question, if you could quickly answer it before we wrap up. Are you planning to work with communication standards agencies such as ETSI or NIST?
Yes, we've had lots of communications with ETSI, and yes, we would be working or following the NIST standards with regards to cybersecurity